Maybe we should just do that from our end then.
So I can press record. Yay.
Going to hand it over to Jeff Creek, who is one of the founders of Carbon Cycle Institute, and he's going to kick off our presentation.
Great. Thanks, Lynette. Really a pleasure to be with you guys today. My background, for my formal education is in rangeland ecology, but I farmed on the Marin Coast for 35 years before starting the Carbon Cycle Institute with some other folks. And for me, as an organic farmer, the role of carbon was always central to my farming operation. But as the climate crisis has worsened, the need to bring these two fields together, the field of agriculture and the question of the fate of carbon in our atmosphere, has become increasingly important. And so with that in mind, we formed the Carbon Cycle Institute to really bring into focus the carbon cycle, the global carbon cycle, as a fundamental process underlying land management and on-farm conservation. And in doing so, hoping to engage agriculture as a climate solution. Next slide, please. Okay. So what is carbon farming? Essentially, it's the intentional management of the farm system to increase the rate at which we remove carbon dioxide from the atmosphere and transform it into the products of agriculture, plant matter and soil organic matter. It's really about engaging agriculture as a climate solution through the beneficial transfer of atmospheric carbon to working land, soils, and vegetation. It's really engaging agriculture to ask the question, how can I make use of more carbon in my farm system, and in the process, reduce the amount of carbon in the atmosphere? Next slide, please. So I think it's critical, and I think as producers, we understand that climate change is a significant threat to our agricultural production. We're seeing it in climatic changes that are having pretty significant impact on agriculture, not just in California, of course, but across the country and across the world. And at the same time, enhancing soil carbon is really the only viable option we have to achieve negative emissions. There's enormous amount of information and financial resources going into industrial carbon removal technologies today, none of which has yet scaled, and all of which promise to be extremely expensive, without providing any ancillary benefit, any co-benefits that would come with increasing the carbon content of our working lands. So we really see soil as the only viable option for achieving drawdown of carbon dioxide from the atmosphere. Next slide, please. So historically and currently ongoing, our land management practices have led to a lot of carbon loss from our working land ecosystems. And these are just some images illustrating that. And the soil erosion obviously is a source of carbon loss from our farm systems. Deforestation clearly is an impetus for carbon loss. And of course, wind erosion is another factor that contributes to significant losses of carbon from our working lands. The graphic in the lower right on this image is an attempt to quantify the amount of plant matter loss, the loss of plant matter over the last couple thousand years from the planet. And with that loss of plant matter has come a loss of carbon from the biosphere, from living ecosystems into the atmosphere. Very significant loss of plant biomass over the last couple thousand years. Next slide, please. Just some more examples of how we lose carbon from working lands. Obviously, Amazon deforestation in the upper left, and use of fire and to clear land. Again, soil erosion and bear fallows, very significant sources of loss of carbon. And again, deforestation in the Amazon. Next slide, please. So, as I mentioned, we have seen a very significant loss of plant matter from the planet over the last couple thousand years, and that's largely due to human activity. Going back 2,000 years, this is a very interesting paper that was published a few years ago, looking at the loss of plant biomass relative to the human population. So 2,000 years ago, we had about 70,000 years of available plant matter to support the human population of that time. And today, following this precipitous decline over the last couple thousand years, we have about 1,000 years of plant phytomass left on the planet relative to our current population. So dramatic decline in overall plant phytomass. A couple of years ago, well, a few years ago now, the Food and Agriculture Organization of the United Nations suggested that our soils globally were so degraded that we probably only had about 60 harvests left overall globally, which is obviously an extremely alarming statistic. So these all are looking at this problem from a number of different directions, but fundamentally, I think agriculture and the capacity of agriculture to support the human population is clearly at risk at this point. Next slide, please. Similarly, this is work by Shramsky and others from a few years ago. Yes, and please do add questions. Be very helpful to discuss this later. This is a model looking at how much carbon has been lost from our soils over the last couple thousand years. Now, this larger graph is showing the increase in carbon dioxide in the atmosphere. And as of just last week, we had about 425 parts of carbon dioxide in the per million of carbon dioxide in the atmosphere. If everything was working normally, we would have about 300 parts per million of carbon dioxide in the atmosphere. So you can see we're really on a very rapid trajectory, upward trajectory of carbon dioxide in the atmosphere. And this is largely a function of our use of fossil fuels and the combustion of fossil fuels and their transformation through combustion into atmospheric carbon dioxide. However, about 27% of that excess CO2 in the atmosphere is a result of soil carbon loss. So a very significant contribution to the global warming equation is our loss of carbon from our soils. And that's the inset graphic there showing loss of soil carbon from grazing lands and croplands over the last couple thousand years. And you can see that rate of loss very, very closely mirrors the rate of increase in the atmosphere. So again, soils contributing very significantly to the global climate situation. Next slide, please. So this is really draws our attention to the global carbon cycle and the question of how agriculture interacts with that cycle and how we can do a better job of interacting with that cycle to the benefit of agriculture. So there are 5 major carbon pools on the planet. The atmosphere, of course, is rapidly increasing its carbon content with great significant and detrimental implications for agriculture and for the planet generally. The oceans have absorbed an enormous amount of carbon, luckily for us, but in the process, oceans are acidifying and are losing their capacity to absorb carbon as they become saturated with carbon. We look to forests. We often look to forests as a source of a sink for carbon, if you will, a place to park some of that carbon. But as those of us in the West are well aware, forests have a very nasty habit of returning their carbon to the atmosphere rather rapidly under catastrophic fire conditions. That really leaves us with the soil as really the only viable potential sink for the surplus carbon dioxide in the atmosphere. And the beauty of soils as a carbon sink is that as we increase the carbon content of our soils, all kinds of good things tend to happen. And so that's why we're really focused on soils as a great place to park some of this surplus CO2 in the atmosphere. And how do we do that? Well, the mechanism we're talking about here is plant photosynthesis. Plants have been doing this for about 3.5 billion years, seems to be working pretty well. And they've demonstrated the capacity to absorb and store large quantities of carbon, not just in plants themselves, but then subsequently into deeply sequestered carbon, which is, of course, what we call fossil fuels. But all of that originating as atmospheric carbon drawn down through plant photosynthesis and integrated into the biosphere and ultimately stored deeply and safely out of the way as coal, oil, gas, etc. Next slide, please. So I often hear folks talking about decarbonizing agriculture, and I'm always caught off guard with that because we can't decarbonize agriculture because agriculture is completely dependent on atmospheric carbon to produce the products of agriculture. So I love this framing by Ratan Lal, preeminent soil scientist out of the University of Ohio, who talks about recarbonizing of the biosphere, recarbonizing agriculture, which is to draw down that lost carbon dioxide and bring it back into our working lands and our natural ecosystems and utilize that, what is fundamentally solar energy, in the reconstruction and restoration and fertility enhancement of our working lands. It's really important to understand that carbon is once it's absorbed by the plant, it represents solar energy that is now part of the ecosystem. So as we increase the carbon content of our working land systems, we increase their energy capacity or their energy content, and thus their capacity for work. And of course, some of that work is the production of the products of agriculture, and some of it is supporting soil fertility, the capacity of our soils to absorb water, the ability to support life, literally, on our working lands. And that energy, that solar energy, then can cascade from the plant to the soil, to microbes, to insects, to birds, to mammals, and ultimately into the human ecosystem. Next slide, please. Now, soils of California are not in the best of shape. When we look at soil organic matter content, particularly in the Central Valley of both the Sacramento Valley and the San Joaquin Valley, we see remarkably low organic matter levels, with some notable exceptions. The Delta, of course, very high organic matter. Some of our coastal, South Central coast is looking pretty good. River areas, riparian systems along Sacramento and so forth, looking pretty good. But overall, our soil organic matter levels are extremely low, well below 2%. In most of our soils in our agricultural soils in California. Now, the NRCS and Natural Resources Conservation Service has suggested 5% organic matter as an indicator of a healthy soil. Now, that's a very generic number, but when we compare that to the amount of organic matter we see in our soils in California, we realize we have a lot of potential to build organic matter in our soils, which means we have a lot of potential to draw down atmospheric carbon into our soils and transform it into fertility and productivity in our farm systems. Next slide, please. So the challenge in front of us, I think, given the rate at which climate is changing and the environmental impacts we're seeing already as a result of climate change, the question really is, are we going to go down the road of 1935 and turn our Central Valley productive agricultural regions into another Dust Bowl, or are we going to change course or alter our course and begin to build back our soils in California? Next slide, please. Now, some of the effects of climate change, of course, we're all very familiar with. We've seen lots of wildfire in California, extreme heat, drought, even some high winds this year that were extremely unusual. We had 100-mile-an-hour winds here on the Marin Coast a couple of weeks ago. Flooding, of course, is we're very familiar with in California these days. So these extremes, these weather extremes, are going to continue to become even more extreme as the energy content of the atmosphere increases due to warming caused by an increase in carbon dioxide in the atmosphere. So all of this is contributing to the destabilization, both of the climate, the global climate system, and of course, agriculture as we know it. Next slide, please. All of this, of course, contributing to an increase in temperatures. This is a graph showing change in California mean temperatures just in the fall months of October and September. You can see the steady increase in temperature over time over the last several decades in California. And all of this, of course, is again contributing to increasing temperatures, decreasing snowpack, decreasing frequency, and increasing intensity of rain events. And that in turn is affecting disease and pest pressures on our farms. Next slide, please. So we have a couple of options. As I suggested already, we can continue down what has been largely an extractive farming approach, where we step onto lands that what we might call virgin lands that have not been farmed, and then we farm them more or less to death, which is sort of the model that we've been using since the mid 18th century. Or we can change course, as I said. So this extractive model suggests that we begin to till our soils, we lose organic carbon from that tillage process. That in turn reduces our soil biodiversity. We see our soils becoming more compacted, crusting is happening, we see soil erosion, and that in turn, of course, is taking nutrients and water out of our systems. And overall, the efficiency of our systems, the resilience of our systems is degraded over time. And this really drives a downward spiral of decreasing farm system energy, decreasing farm system carbon, decreasing farm system resilience, and ultimately decreasing farm productivity, requiring more and more inputs over time as we lose the native fertility of our farm systems. Next slide, please. And an illustration of that is this is an image from a farm a couple of decades ago in Marin County, looking at sort of the net effect of about 100 years of historical farming practice, in which this riparian system had been channelized to drain the pasture systems on either side of this channel. The grasses had been heavily grazed for well over a century. And we see a system that is really heading in the direction of desertification, where increased grazing intensity has decreased soil cover, soil organic matter has been lost, water is unable to infiltrate compacted soils, channelized stream is downcutting and degrading, and overall we see an overall loss in organic matter from the farm system, or carbon from the farm system, or we might say a decrease in the energy content of the farm system. So next slide, please. So the alternative model then is to begin to recarbonize our farm landscapes, to increase our soil organic carbon, which in turn results in improvement in soil aggregation, which means we can hold more water, we can support more biological activity in our soils, we can hold on to nutrients in our soils, we can increase our soil biodiversity, earthworm activity, and so forth. Obviously, we're strengthening our nutrient cycles, we're holding more water and improving our water cycling capacity. We're improving the rhizosphere biodiversity, that is that very active biological zone around the plant root. We increase our net productivity overall, which means we have more carbon both to sell in products, but also then to reinvest in our farm system, in our soils. And finally, we increase the use efficiency of whatever inputs we do bring to the system, and we conserve soil and water in the system. And all of this leading to an upward spiral of farm system energy and farm system carbon, with ancillary environmental benefits, improved water quality, improved water quantity, and so forth. So this is an alternative, and very real alternative, that we have in front of us as agricultural practitioners. Next slide, please. And this is an example of that same farm system after 20 years of restoration effort, in which the riparian area has been largely revegetated. The adjacent meadows are beginning to rehydrate. Their soils are being restored. Their organic matter is returning. More water is being held in the system, and overall pasture production is increasing. And so as we increase the carbon content of our working lands, we increase their capacity to hold water and to increase production additionally. So you can see carbon being held in all of that woody biomass in the riparian system, but also, of course, the improved photosynthetic capacity of that newly rewatered meadow system adjacent to the riparian zone. Next slide, please. I really want to hit hard on this hydrological question because water and carbon are intimately linked in the soil. This is a really important piece of work recently done by McDermott and others, where they recognize that the hydrological impact of soil organic carbon loss has been equivalent to the impacts of climate change in the southwestern United States. In other words, the loss of soil carbon has effectively doubled the impact of drought in California and the rest of the American Southwest. So restoring and enhancing organic carbon in our soils is absolutely essential, both to mitigate climate change and to build resilience to these climate extremes within our farm systems. Next slide, please. So we have choices in how we manage our landscapes. Just sort of a graphic illustration here of a orchard that's managed with a bare fallow versus an orchard that's managed with a cover crop. And you can imagine, on the one hand, the amount of carbon being drawn down by that, what looks like a pretty heavy mustard crop there in that walnut orchard on the right. And then on the left, we see a walnut orchard that is being managed with bare fallow. And in which case, not only are we not able to capture carbon with that cover crop, which is missing in this case, but of course that soil is being hammered by winter rain, potentially vulnerable to soil erosion and soil damage. So these are just a very simple example of the kinds of choices we can make on farm, one of which builds organic matter in our soils and one of which leads to a gradual degradation of organic matter in our soils. Next slide. We can build soil carbon very, very quickly. This is from a vegetable operation on the Mendocino coast. The upper left image is the native soil in year 1 on this farm. When this farmer took over, it started growing produce on the Mendocino coast. The soil had an organic matter content of 1.5%. Within 3 years, on the right side, she had 4%, and within 4 years, she had brought her soils up to 6% organic matter. Now, she did this with a lot of compost, and that's an obvious, quick, and easy way to increase soil organic matter. But she also instituted cover cropping, abandoned bare fallows, and she stopped tilling her soils. And so very quickly was able to build soil organic carbon in her soils with a dramatic transformation, as you can see, in a very, very short time. Next slide, please. Lots of other practices. This is just a few examples. There are over 35 identified by the Soil Conservation Service. But cover cropping, windbreaks, of course, if you can imagine how much biomass gets tied up in a windbreak. And then that windbreak, if it's deciduous, for example, can provide leaf fall into the adjacent fields. It provides habitat for beneficial insects and birds. And they bring, of course, all of their fertility with them when they used a windbreak as habitat. Recent paper on the effect of reforestation in the Southeast has suggested that on a regional basis, by introducing trees at scale into our landscapes, as we might do in the Central Valley with adding windbreaks and hedgerows at scale, we can actually begin to reduce the temperature regionally, not just at the farm scale, but at the regional scale. Very exciting work done recently out of the southeastern US. Avoiding tillage where we can, that's not always possible, but it does mean losing less carbon from our soils. Soil organic matter amendments, of course, critically important. Very rapid way to build soil organic matter. Silvopasture, where we integrate livestock and trees together, can be a very productive, carbon-rich approach. And then, of course, integrating hedgerows, which Yolo RCD has done such an incredible job of modeling for all of us. A very good way to build soil carbon. It would also provide insect and beneficial bird habitat. Next slide. Ultimately, we can manage our farm system processes, that is the flow of energy through our farm system, by choosing the right farming practices in the right space, in the right time, the right scale. I want to emphasize that practices themselves are not regenerative. but they can drive regenerative processes. That is, processes that result in increased flow of energy, solar energy, into and through the farm system, which is essentially the increased capture and storage of carbon within the farm system. As the American Farmland Trust recently suggested, we need to stop looking at single practices and start thinking about the whole farm system, integrating multiple practices in a whole farm plan, which is, of course, the basis of carbon farm planning. So we can focus on practices that build soil carbon. We can focus on practices that increase biomass carbon, and we can focus on practices that reduce greenhouse gas emissions. But all of this together in a whole farm plan or a whole farm context is really the fastest and most comprehensive way to really begin to build the energy content of our farm systems. Next slide, please. Okay, I'm going to pass this off to Lynette, and she's going to get into the nitty-gritty of carbon farming. Thank you.
All right. Thanks, Jeff. That was great. I hope all of you were able, I'm trying to find my video here. I hope that helped all of you understand a little bit about the background of why we really focus on carbon farm planning and cultivating carbon farmers through this process. So now we'll get into really talking about carbon farming and what is a carbon farm plan. So as Jeff has already said, a carbon farming really is all farming, which is completely dependent upon atmospheric carbon dioxide in order to produce its products. But every farm that we work with has different farming practices, a different farm design, and can lead to different amounts of carbon capture and loss on that farm. So it's not a one size fits all, because you all have different farming practices and landscapes in which we look at, and to be able to determine what your whole farm plan will look like. So what is carbon farm planning? As Jeff alluded to earlier, it is a whole farm approach to optimizing carbon capture on a working landscape. And we base this off of the NRCS conservation planning process, but we really organize our thoughts and our recommendations of potential carbon capture around carbon, and how can we really think about increasing our carbon sequestration. So thinking about that photo Jeff showed earlier of the 3 different types of soil, it's not just one practice, it could be many practices stacked upon each other, that we're really thinking about how we can sequester more carbon. And really, this whole farm approach really lays out the whole entire farmland and what is that potential. So it is a creative exercise, and we identify all opportunities on the landscape. All opportunities may mean that these are practices that you may achieve and implement in the next 3 to 5 years. But what we're really doing is trying to think about what this landscape is capable of on your farm, and thinking like 20 years out. So oftentimes we work with producers, and they only want to plan 3 to 5 years because that's what they know they can achieve. But we want to go beyond that. We want to think about, okay, after you do achieve that, what is beyond that? And after thinking about how easy it could be to implement these practices, what are those other things that then come along? So oftentimes we plan for things and thinking into the future. Just because they're in a carbon farm plan doesn't mean that you have to implement them. It's just giving you the idea of what that potential is on your farmscape. And we're outlining that for you in a carbon farm plan, what your potential is on your landscape. So really, these plans can also be a vehicle for increasing climate and carbon cycle literacy among producers. So we train technical service providers to work with you, because we've trained them up to be able to talk to you about carbon farm planning, about carbon farm practices and other conservation practices that may not be climate beneficial, but they are supporting, and that they will help facilitate a practice. We also, these plans also help to build climate and agricultural expertise among our RCDs, like Yolo County RCD. And it's really can be a roadmap for climate mitigation opportunities in the whole farm, ranch, and regional framework for your county. And most importantly, these carbon farm plans are cultivating carbon farmers and helping you understand how you can maybe transition some of your operations on your farm. One of the things we do like to emphasize that what we really look at as opportunities, we're not focusing on what problems are on the landscape, problems being an example, erosion. So we're not looking at erosion and telling you that's an issue right there. We need to figure out how to fix that. We're thinking about it like, oh, wow, that's an opportunity for planting and for sequestering more carbon. What else could go into addressing that erosion? What are those other practices that we can think about that would address that? Because that's an opportunity for covering that landscape and from mitigating any loss of soil. So we really do develop these with the producer in mind and the producer at our side while we're creating the plans. So just a couple parts of and elements of a carbon farm plan is really focused on working side by side with the producer and that engagement. So we can get to know your landscape, get to know your farm, and really get down in the weeds of like what your goals are. And we do this through site visits, mapping out the practices, mapping out the farm, and then quantifying it through one of our models that we use. The end product is a full written plan. And then after the plan is written, then we work with the producers, yourselves, to figure out how we can engage going further and what types of practices or projects that we can pull out from your carbon farm plan that we can really focus on implementing and how we can get that funding to implement those practices. Starting small is something I always recommend. If it's a new thing for you, we start small and then make sure you're perfecting the implementation on that with a technical service provider. And then you could go bigger once you know exactly how to implement that practice efficiently and effectively on your landscape. So just to give you an idea, quantifying benefits on your farmscape, we normally use Comet Planner. There are other models that you can use for quantification, such as using this greenhouse gas flux and agricultural blue book. This is actually being updated right now, but a lot of this information in here feeds into Comet Planner. We also use peer-reviewed or local data that is specific to that area. If it's something that we know in the carbon farm plan, we would like to model it the exact way of local data where it has been peer-reviewed and researched. We oftentimes use that. And like I said, the Comet tools, which are Comet Farm, Comet Planner, and in our field day, I can go through how to use Comet Planner with folks who are interested in learning how to navigate through that. So an end product is a full map showing all of the conservation plans or climate smart plans practices on a landscape and outline where they are in the legend so you can identify what those practices are. I do want to say that oftentimes these carbon farm practices that we talk about or climate beneficial practices we talk about do go hand in hand with supporting practices. So in our carbon farm plans, we do not um, we do not put them in. So we're always thinking about, okay, if we're going to try to do rotational grazing, we're going to want to implement water systems like this, or we're going to put in fencing right here to fence out, our riparian area so we can do restoration there. So other practices are in these plans, and it's important that we do think about all of that because those are opportunities for helping us drive that practice that will sequester carbon. And then it's also important because that also helps us secure funding for those supporting practices. We don't want to forget those because sometimes a lot of funding opportunities do not include those. So by having them in a carbon farm plan, we're able to justify the importance of those. So some of the co-benefits are really thinking about our GHG reductions, increased soil fertility, increased ag production, improving water quality, wildfire resilience. And this also helps us, with job opportunities, increasing biodiversity, farm and regional climate resilience, and landscape connectivity. So you're probably thinking, like, what are those economic benefits? Well, the plan can, help a producer maybe access price premiums. So we do work with Fibershed quite closely and their wool growers and cotton growers and help those producer access price premiums through by having a carbon farm plan and by doing implementation. These plans can also help access grant funding for implementation, and really it helps you identify the impact of the whole farm if you were to implement these practices. Once completed, once everything is implemented, you can really think about it in a perspective of it's going to help reduce your input costs. You have increased productivity, yield resilience over long term, potential impacts on the land or crop insurance, payments for carbon or other ecosystem services. So the next thing before I end this presentation is just to help you guys think about this in a different context, that we are helping and looking at helping to create these carbon farm plans on a field scale right here, with the RCD and helping to implement. But these carbon farm plans don't stop here with you. They actually go on to thinking about what an aggregate of all these carbon farm plans in your county could look like to help influence a climate action plan or regional opportunities for assessment and really reporting to local policy. So thinking about it on a bigger scale, that these plans actually do feed into a larger scale of what we're trying to move through our policies. And then also these plans also go into state, national, and a global scale, thinking about climate and agricultural policies, funding programs, and global climate change impacts. So a lot of this work that we've been doing over the last 10 years or so has really helped influence that funding that we're getting from the Healthy Soil CDFA. So just think of it as you may be one small farm, but really your one small farm is having a greater impact than what you think. And then that is all we have. I went through that pretty quickly, but we'll go over more of that in our site visit together at the Center for Land-Based Learning. I want to make sure we have a little bit of time for questions.
Yeah, I'm going to take you off spotlight, I think, so that folks can ask questions. There's a couple of questions in the chat. Hang on a second. Okay, here we go. All right. I'm just going to read through each one of these, starting with Tom's question. I think this was during Jeff's presentation, asking if has the stream from that image that you showed stopped degrading and begun to aggrade. So has the stream in that photo from several years ago stopped eroding, and is it repairing itself?
Yeah, definitely. It's definitely stopped down cutting. It's not down cutting at all at this point. And I have to assume it's aggregating since no doubt it is accumulating some material from upstream beyond the property line where that restoration work hasn't yet taken place.
Thank you. And then there's a comment from Muriel that there are other practices, including holistically managed grazing and incorporating biochar. Muriel, do you want to add to that, or Jeff, do you want to discuss that? those practices?
We don't want to.
Are you familiar with them?
Yeah, absolutely. Yeah.
Okay.
Absolutely. Yeah, managing grazing for soil carbon enhancement is a great strategy. It's very site specific, which is what holistic grazing is all about. So understanding, how to manage livestock for soil carbon enhancement is a really important skill for anyone running livestock as part of their operation. Biochar can be a great way to quickly increase soil carbon. Of course, you want to be clear about how your biochar was made, where it's coming from, what materials it was made from, to make sure that it's actually a climate benefit and not in some way contributing to further atmospheric CO2.
Are you aware that biochar can, if it's done right, store that carbon for hundreds of years?
Yeah, I certainly am, and it is a very durable material. No question of that at all. So it can be a really great way to build soil carbon, permanent soil carbon. The question of permanence is an interesting one when we talk about carbon cycling, but given the climate situation, storing carbon for long periods of time can be extremely helpful. Absolutely.
All right. Thank you, Jeff, and thank you, Muriel, and everyone is asking questions here. There are two related questions about using native plant species for cover crop situations, and I can take. I answered. Did a little quick answer there, but
I like your answer, Heather. That's a good one. Yeah, typically cover crops are a temporary thing, and so we typically use annuals, and they mostly have been non-native historically. There are some native annuals. There's a native Vulpia that gets used as a quick cover, and there I am aware of folks who've used a native trefoil, native lotus species as a cover, but not a short-lived cover because that's a perennial species. So it's maybe a question as Heather calls out here, between permanent cover and a short-lived cover crop where you might plan on tilling that in and planting your market crop. So access to affordable seed is usually a factor in cover crop selection, and native seed tends to be pretty pricey for something that you're going to till in within a few months of sowing it. So, but definitely lots of room for work in that arena for sure.
yeah, I would say we've done quite a bit of native grass and native wildflower pollinator establishment, and it's more of an investment for long-term typically. If you want, permanent ground cover, like under a hedgerow that you're not going to be taking out every year. And then cover cropping really depends on the crop types that you're working with. And we can talk a lot more about that. If you want to work on a plan with us. Let's see, what else do we have here?
Quickly on that topic, Jeff just added that Hedgerow Farms is working with a few growers to get native cover crops into their mixes, Phacelias and fescues, annual fescues.
Awesome. There's a question from Kathleen. Are there new voluntary or compliance protocols for carbon payments for smaller scale carbon farm projects?
The carbon market has not served agriculture particularly well to date. I think we might hope for something down the road. There is a biochar protocol that's now effective or active that might be worth looking at if you're using biochar. But overall, the protocols I'm aware of, rice protocol, rangeland compost protocol, have essentially been sitting on shelves unused since they were written, because the cost of implementing a protocol tends to outweigh the benefit economically of doing so. So unless you're doing these things for your own reasons to build soil carbon, et cetera, you're trying to do this as an economic enterprise. At this point, there isn't much out there that's going to pay enough to actually warrant doing, meeting all the terms of the protocol, which typically involve a lot of sampling and really some intensive work that is difficult to justify economically when you look at the rate of return for these protocols. I don't want to discourage folks from keeping abreast of that information, though, because I do believe that as we scale carbon farming, folks are going to start, those who write protocols and those who fund those things, I think, are going to begin to recognize the potential of agriculture in a way that hasn't been recognized up to this point.
Okay, there's a lot of questions coming in. I want to give maybe like 5 more minutes for questions before we keep going with the content for the webinar. And then there will be time again for, we can finish questions at that point. Does that sound okay with folks? Okay. So I'll take another question from the chat. From another person, we can come back, Muriel, to conversion to organic. Robin is asking about, are you getting a baseline to then be able to quantify how much carbon is captured once practices are implemented? If so, how are you measuring? And I think that's the COMET planning tool that we typically use, Jeff.
Right. We're typically using the models. The COMET Planner is the preferred model just because it's so easy to use. We tend to, with a carbon farm plan, we tend to assume we're starting at 0. Of course, that's not ever the case, but we tend to assume we're starting at 0, and then we look at what additional carbon will the implementation of a specific practice on a specific number of acres yield in terms of increased carbon content. It can be really helpful to do some soil sampling up front before you actually begin to implement your carbon farm plan, so that you have that data. And so that if you choose to track changes in soil carbon over time, you can do so. The challenge there is determining, okay, what is it I'm really trying to measure, and what is it I'm really trying to keep track of at what scale? Because a farm system typically involves enormous variability across the landscape. And so while we can fairly easily quantify carbon in a single soil sample, when we try to quantify carbon at the landscape scale or the farm scale, that's a very different challenge, and ultimately a very expensive challenge if we actually want to assume some accuracy in the numbers we're getting out of that effort. So it really comes down to, what's the goal? What's your purpose in sampling, and what is it you're trying to monitor over time? And if you're really clear on that question, you can develop a sampling protocol that will provide you a reasonably reliable answer over time.
Okay, I'm looking through the chat as well. There's a lot of these questions are getting answered in the chat, and also will be answered in Connor's and Amy's presentation. But I will take Ahmad's from Fiber Shed. I'll take your hand. I see your hand raised there. Ahmad, do you have a comment or a question? And then we'll move on to the next part of the webinar.
Thank you. So, and it's interesting, you just touched on it. Love your last name, by the way, Mr. Creek, with the work you do. I'm just being introduced to the data capture and reporting piece in terms of this, and it's been a confusing process, not just for me, but other folks that are producers, but also in a compost project that I work on. So I'm wondering what level of follow-up or ongoing technical assistance or support there is or could be developed, especially culturally relevant, since I'm in the Central Valley and we have a quite diverse ag population here. Particularly my work is with BIPOC communities. So again, through that kind of more granular lens, what work is being done to connect those dots? Because I'm kind of one of the smart ones, and it's tough to negotiate all those calculations and all those things. At least with the method, the COMET method, and I know there's other things. So in that whole space of things, what do you have? What could you offer or suggest? And thank you for the opportunity.
Yeah, great question, and not an easy one to answer. I think the fundamental question is why are you measuring? What are your goals with measurement? What are you trying to achieve with measurement? And that's really the core question, because we can measure any number of things at any number of scales, but at the end of the day, why are we doing that? And so that answering that question up front is really critical. What do you and the producers you're working with need to be measuring, and why? Sort of what's in it for them. We, as Lynette mentioned, we work primarily with resource conservation districts, precisely because we want local boots on the ground to interact with producers, because we know there's that need for technical assistance at every level in this work. And as we all know, our resource conservation districts, for all the good work they do, are really underfunded and under-supported. And that's part of what we do, is try to promote that increased technical assistance on the ground. So it might be good to have a one-on-one conversation about where you are located, what technical assistance might be available to you, and how we might be able to support that, because definitely you're making an excellent point, and that TA is really critically important. So thanks for asking that question. I'm sorry I don't have a better.
Thank you. I'd be happy to, because I do work regionally, so it's not just for me. Like, this will help a lot of people in the region, mostly small farmers. So
great.
Thank you again.
Excellent.
Thanks for your questions, and thanks for all the questions that are coming in, and we'll do our best to get to them. But I am going to go ahead and turn it over to Connor to talk about, basically what Jeff started talking about, how RCDs are working with carbon farm plans and the funding sources available and all of that. So Connor, I'm gonna spotlight you, and thanks everybody for tuning in.
Thanks, Heather, and thanks everyone for those questions. Keep them coming in, and we'll kind of cruise through this part and hopefully be able to answer a lot of those questions here at the end. Let me share my screen. All right, so yeah, I just wanted to highlight some of the resources that are available, resources both in terms of funding and in terms of partnerships or organizations that you can work with. We kind of just touched on that a little bit with some of those questions there. This list, I try to just break it down logically, starting federal, state, and moving kind of more local, working with tribal partners, nonprofits, private organizations. And just something to keep in mind as I'm going through it, a lot of funding sources are tied to a practice, or they're tied to an outcome. So I just wanted to put this list up here again. This is not an all-inclusive list, but it's just a smattering of some of the practices that do tie into carbon farming. So keep that in mind as we go through this. I have worked with some of these programs, haven't worked with all of them. So if there's other experts in the room that have had experiences with some of these programs that I go over, chime in and let folks know what your experience was. So at a federal level, probably the one most folks are familiar with is Natural Resource Conservation Service. They have an EQIP program and a CSP program. Sorry, this is going to be a lot of acronyms. I'll try to make sure I say them all. Environmental Quality Incentives Program and a Conservation Stewardship Program. That first one, the EQIP program, provides funding for implementation of a new practice that hasn't been put on that land already. Whereas that CSP program builds upon practices that already exist there and tries to enhance them and make sure that they continue into the future. There's different pools that open up for those funding sources kind of each year. And so it's good to plan ahead. And so this kind of ties right into creating a carbon farm plan. A lot of these practices that we're devising in this plan can then be funded through a program like EQIP. So having that plan ahead of time ensures that you haven't already put it on the land and you can qualify in one of those funding pools. Fish and Wildlife Service as well has some programs that oftentimes tie back to wildlife. So things like pollinator plantings, riparian related work. And then this last program, I am going to call that by its acronym REAP because it's a really long program name. How I've not worked with it directly, but how I've seen it kind of in our offices, folks coming in and applying it towards things like a tractor upgrade or tractor replacement. It supports practices that decrease greenhouse gases with infrastructure systems. So equip, you will see on our field day, there's examples at the maples, a lot of plantings, hedgerow plantings there. As Heather and folks have already said, the RCD is a big part of those plantings, or can be a part of those plantings, the implementation of that, and can serve as a technical, kind of a technical source of assistance when designing those plans. Equip, also just inherently, you're working with NRCS personnel as well, so they'll be providing technical assistance there too. At a state level, again, this is just a smattering of some. CDFA, California Department of Food and Ag, has put out recently Healthy Soils Program and the State Water Efficiency and Enhancement Program. HSP and SWEEP are their acronyms. Healthy Soils Program deals with pretty much all the practices that we talked about and that you'll find in Comet Planner. It's linked to Comet. And so it'll cover things like cover cropping, compost application, reducing tillage. It's a long list of practices that are aimed at supporting soil health. And there's funding actually open right now. I'll cover that a little bit more here in a few slides. SWEEP, it's more geared towards water conservation, but there's a component to those applications that it also, each project must decrease greenhouse gas emissions. So oftentimes what folks wind up doing is using it to maybe support a solar installation at your pump station. So that's something that can tie in to a carbon farm plan as well. CDFW, California Department of Fish and Wildlife, and then the California Wildlife Conservation Board. Programs through that often will tie in as well to things that support wildlife, pollinators, so things like hedgerows, practices around riparian restoration or riparian plantings can tie in as well. This is just an example of a pollinator planting that was done through Wildlife Conservation Board. Yeah. I said I wanted to highlight HSP, Healthy Soils Program, a little bit because right now there is funding open. So folks might have heard about the direct to grower application that was open, I think, and just closed a week or two ago. That was where producers could apply directly to CDFA to get funding. But they have another format as well where it's called a block grant style format. So they're kind of piloting this. This is a new program where organizations applied to CDFA to then administer funds to producers. So producers would be applying to this block grant organization to get funding rather than directly to CDFA. And if you're in Yolo County, farming or ranching in Yolo County, there's a few opportunities actually to apply, and each organization has their own timeline, has maybe slightly different requirements, but generally they'll run similarly. And we're fortunate to be pretty well funded here in Yolo County, and actually the Sacramento Valley got a lot of funding available. I know it's not quite the same down further south in the state, but I think up here we have at least $10 million going towards Healthy Soils Program. They also started using a new tool, so it's called Replan, and it's actually a pretty cool tool. It helps make this process a little bit easier and a little bit more streamlined. You'll zoom in on your property. I just chose the maples here, and you can actually just draw a polygon around a part of that property, and you'll be indicating in their form what practice you want to do on that field. So for example, if I want to do cover cropping in here, I would select that, go through a list of what species I might want to include in that. And it does a lot of the legwork for you. It will produce a report that tells you how many acres you would be applying for based on that polygon you drew, the reduction potential in greenhouse gases, and then the amount of funding that you could receive for that. And so I will actually be helping serve as a technical assistant for one of those block grants through Solano County Farm Bureau. And so I can help, through this process and navigating this software. But it's pretty user friendly from my experience so far. And I guess I'll just add that Healthy Soils program is, like I said, pretty well funded, and it can provide up to $100,000 per project. So you can add on multiple projects. Here is only $3,700 in funding. If compost application is something you want to do as well, or hedgerow planting, you can add on multiple practices. Some other resources. There's opportunities for tribal collaboration and connection. So Yochadihi is pretty active with at least some of the programs that we've worked with. Xerxes Society provides kits for planting, so it can be a pollinator planting. They have riparian versions as well for those plantings. Zero Footprint has grants that provide up to, I think, $25,000 for regenerative agricultural practices. Project Apis M provides seed for things like cover crop. And then National Fish and Wildlife Foundation, there's opportunities for plantings as well, again, for things like hedgerows to support butterflies and other pollinators. I'm going to pass this off to Amy. She's going to speak a little bit to these programs, but also kind of the partnerships and how the RCD can kind of act as a pivot point in some of those partnerships. So Amy, pass it off to you.
Connor.
Mm-hmm.
I'm not sure if I need to pin myself on here or not, but I'll try to make this quick because I know there are a lot of questions. So I just wanted to talk for a minute about working with the RCD on the implementation of some of these carbon-friendly conservation practices and how we leverage funding and partnerships to assist with this. I'm focusing here mainly on native habitat enhancement projects that, like Jeff and Heather have already alluded to, like hedgerows and windbreaks, riparian restoration, native grass and pollinator cover. The RCD works with farmers and landowners and other stakeholders throughout the county to help connect them with resources and provide technical assistance to help with these. Connor's already mentioned a couple of examples of EQIP funded and WCD funded projects at the Maples, which we assisted on and that you'll be able to see during the in-person field day. Photos in this slide show an RCD, just as an example, an RCD led project that utilized a tribal grant matching funding from Partners for Fish and Wildlife, and an in-kind donation of plant materials from the Xerxes Society to help install a pollinator hedgerow in a riparian restoration area. As seen in the picture at the top, you can see a group of high school students there. This is part of the Center for Land-Based Learning's SLUES program. They bring high school students out where they participate in up to 3 field days. It's their entire school day. They provide a lot of labor to help install the project while learning about the nuts and bolts of installation of irrigation and plants and that sort of thing, caring for these sites. And I think in that picture, they're learning about native spiders, if I remember correctly, because there are mentors that help them and facilitate getting the day done. We also work with community volunteers from Cedar Creek Council. The bottom photo even shows staff from Partners for Fish and Wildlife who came out. All these people are providing labor to help plant these projects. And that is funded by primarily the Yochadihi tribal grant. Let's see here. So we often work with NRCS on sourcing EQIP funded projects that we can bring matching resources to. And then our job is to help ensure that the projects go as designed. So we can help source local ecotype plants and other materials. We coordinate activities with the landowner, everything that happens on the property with the landowner and all the other participants. And in the past, we've been able to access Partners for Fish and Wildlife funding on behalf of landowners, and that provides additional funding for supplies, plants, RCD staff time to help provide follow-up care during the very important establishment period. By the way, the Partners for Fish and Wildlife program provides free technical and financial assistance to landowners, managers, tribes, a lot of others who are interested in improving wildlife habitat on their land. So outcomes, you can change the slide. So these partnerships and funding sources, when they're available, can allow us to provide technical assistance and support during all phases of the project, help us create resilient, successfully established projects that comply with the grant requirements that might be in EQIP or healthy soils that Connor was talking about, and are designed to provide multiple benefits, including carbon sequestration, of course, structurally complex wildlife habitat, erosion control, non-weedy ground cover, et cetera. And then with the added benefits of providing environmental education opportunities to high school students, connecting community volunteers to their local landscape and that sort of thing. So that's all I've got. I'll be happy to answer any questions about working with the RCD and the Q&A session or in the in-person field day.
Great, thanks, Amy. Let me actually skip forward to this slide quick here. So I saw a question in the chat about working with CCI or creating carbon farm plans. There's actually a lot of RCDs. There was a grant that became available for RCDs to do conservation planning with growers. And so there's actually funding for several RCDs to do carbon farm planning as well as nutrient management planning, which is geared towards ensuring that you're putting down the right nutrients at the right time, right place, and the right quantities. Soil health management planning. So it winds up tying pretty closely into carbon farm planning, but if you have soil health concerns, maybe of compaction or low organic matter, devising a plan to improve soil health, or pollinator habitat design is a fourth one as well, that at least Yolo RCD has something for designing hedgerows. These opportunities are also available. So I would definitely encourage folks to seek out their RCDs or local organizations, because beyond just Carbon Cycle Institute, there's other organizations that were actually trained in a lot of cases by Carbon Cycle Institute to help implement, or to help, I guess, design plans and carbon farm plans. So that's just another consideration there. These four that I highlighted are ones that Yolo County RCD actually has the capacity to work on for folks. So if anyone's interested in these types of plans, definitely reach out to us. But with that, I want to open it up maybe back into Q&A and also just hear from you all. What other sources of funding or collaborations do you know of, and what are your experiences with that? So I'll open it up to folks. I guess one housekeeping thing, I just want to give people an opportunity. If you signed up for CCA CEU credits, you can scan this. I'll hold this here for 5 seconds. And if you signed up for other CEU credits, just email me afterward and we can make sure that you get those. But yeah, let me open it up. I'll stop sharing here. And I'll put into the chat those two questions. And we can also, let's make sure we answer all the questions that were already asked as well. Maybe Heather or someone who's been keeping their eye on the chat, if there's anything still outstanding.
Yeah, this is great. There's a lot of questions. I think, because we're wrapping up at 11:30 and want to respect people's time. But we can also, try to follow up after this webinar. Just in case you didn't hear this at the beginning, we are recording this and we can send it out to everyone on this list, and we'll also put it on our website, I think is what the plan is. Yeah, there's some specific questions that maybe are better to work on one-on-one. Oh, can you please share the education credit screen again at the
Yeah.
end? Yeah. Yeah, I
Yeah.
know there are farmers here who are definitely wanting to get their continuing education units, and we want to make sure you get that.
Let me just go ahead and share now. Here. We also have a survey that we would like folks to fill out as well. But go ahead. Here's the CCA credit, and there's also CDFA INMP credits available. I don't have an online version for that, so just follow up with an email. I'll put my contact information in the chat here in a second.
So many great questions. I mean, there's a really quick one about, cover cropping, and there's people in the room may be more experts than I, but typically cover crops are for annual rotation are terminated before they go to seed. And the reason for that is so that most of the carbon stays in the material. It gets incorporated back into the soil. If they go to seed, those nutrients go into the production of seed, and will then not be available to plant to the, whatever crop you're planting afterwards. But like I said, like having, if you're looking at, long-term cover and you want to put in native pollinator seeds, for example, or wildflower seeds for orbs, and you're looking at creating like a permanent cover crop that reseeds itself year after year, which, can be done with native or non-native cover crops. If that's what you're looking to do, then that's a different kind of cover cropping. There's a couple different kinds of cover cropping. There are some that are more long-term. And does anyone want to take the rest of that answer?
Yeah, I'd just add that in many cases, that one of the objectives of a cover crop is to reduce weed pressure in the subsequent crop. So if you allow that crop to go to seed, that cover crop to go to seed, you may be setting yourself up for some real weed management issues in your subsequent cash crop.
Emma Torber, I think Full Belly has a roller crimper that you might be able to rent, as does UC Davis. Okay, this is a really good kind of piece of homework for us too, is to follow up on where a no-till drill could be borrowed or rented. And we have a rice roller. I don't know if there are any rice growers in the room, but that's something that we rent on a per acre basis. But those do come up. There's special tools for compost spreading, for no-till drilling, for those are two big ones that come to mind. That we'd like to see if it makes sense to help with. So thanks everybody for tuning in. We're 1 minute past our time, and I think we should thank you for coming. We should end on time, and it's just really, it's been I hope it's been useful for y'all. And we're going to make sure that the link and the recording is readily available for anybody who missed that.
Great, thanks everyone. Yeah, we'll follow up with a survey link as well. We'll send out to folks, and we'll send out an invitation to register for the in-person field day, which is just 2 weeks away. So if you're interested in coming to that, please join us. We want that to be very grower focused and centric. So it can be a lot of resource sharing and be very practical and helpful for folks on our working lands. Yeah. I'll put my info in the chat if anyone has follow up as well that they want to send my way.
Great. Thanks, everyone.
Thank you. It was nice seeing everybody.